Welcome back to my channel. I am Shailesh here. I hope you're doing fine today and you're going to learn something new today. Today we are going to do deep dive into various aspects of developing the AI agents. We will leverage the example of a cleaning robot to explain the various aspects. So let's start. The first thing is to understand the problem and define the goals. Before designing your AI agent, you need to clearly define its purpose and the problem it will solve. So you need to ask yourself, what tasks will the agent perform? What environment will the agent operate in? What are the success criteria for the agent? Example, for a smart cleaning robot, the goal is to clean the floors of a house efficiently while avoiding the obstacles for furniture or the pets. Choose the right environment. The environment is the space in which the AI agent will operate. It can be physical, like a factory floor, your house floor, or the virtual environment, like a simulated game environment. Consider these factors: static versus dynamic. Does the environment change over the time? Then deterministic or stochastic. What are the outcomes? Are they predictable or probabilistic? Okay. So what is deterministic? The outcome of an action is always predictable and consistent. For example, if your cleaning robot moves forward by 1 meter in a clear area, it will always end up exactly 1 meter ahead. Stochastic. The outcome involves some randomness or uncertainty. For example, if the cleaning robot moves forward in a crowded room, it might get partially obstructed by furniture or pets, leading to varied outcomes depending on the exact circumstances. Fully observable or partially observable. Does the agent have complete information about the environment or not? If it has complete information, then it's fully observable. If it's not, then it's partially observable. Example, the environment for the cleaning robot is a house, which is dynamic. People and pets move around, and partially observable. The robot may not be able to see behind the obstacles. Then we have to define the agent's architecture. The architecture outlines the core structure and components of your AI agent. The common architectures include reactive architecture, which is simple stimulus response behavior without the memory. The agent reacts immediately to environment inputs without considering historical data or planning. This architecture is suitable for tasks that require rapid responses. Yeah. An environment is mostly static. Yeah. The example is a cleaning robot stops immediately when it detects an obstacle, such as a toy or furniture, without further analyzing its surrounding area. Then we have something called deliberative architecture. It's a decision making based on planning and reasoning. The agent analyzes the environment, uses its memory, and plans a sequence of actions to achieve a goal. This is ideal for tasks requiring complex problem solving. Example, a cleaning robot maps the house layout, identifies dirty areas, and plans an efficient cleaning path before starting. Then we have hybrid architecture that combines reactive and deliberative elements for efficiency and adaptability. It uses quick reflex like responses for immediate actions and deliberative strategies for goal-oriented tasks. Example, the cleaning robot reacts instantly to avoid obstacles, which is reactive, but plans its cleaning path for maximum coverage, which is deliberative. Then we have building the key components. So here we have like perception module, which collects and processes the data for the environment. Sensors or data streams provide input which is filtered and interpreted for decision making. Example, the cleaning robot uses a camera and proximity sensors to detect dirt, furniture, and walls. Then we have memory module, which stores the knowledge about the environment, rules, and past experiences. Can include both short term, which is recent events, then long term memory, that is learned patterns from the data it is receiving from the environment. Examples, the robot remembers areas it has already cleaned and avoids repeating the same spots unnecessarily. Then we have planning module, that is analyze the current state and formulate a plan to achieve the agent's goals. Often uses search algorithms, optimizing techniques like gradient descent to optimize the function in machine learning or rule-based systems. Okay, so what are the various search algorithms that you can leverage? The first is like breadth first search, BFS. It explores all the possible actions level by level. Then we have depth first search, DFS, which explores as deep as possible along a path before backtracking. Then we have A star algorithm that combines search with heuristic optimization for efficient pathfinding. Example, the robot calculates the most efficient path to cover all areas of the house while avoiding the obstacles. Rule-based system uses if-then rules for decision making. They are simple but effective for environments with well-defined behaviors and almost static kind of thing. Okay, so like you could have rules like if the battery is low, below 20%, then return to the charging dock. If an obstacle is detected, then stop and calculate a new path. Action module. This module executes decisions and interacts with the environment, converts plans into concrete actions using actuators or commands. Example, the robot moves forward, turns or stops based on its plan and sensor feedback. Then the learning module, which enables the agent to improve over time by learning from data or the interactions. This includes techniques like supervised learning, reinforcement learning, and unsupervised learning. Example, over the time, the robot learns which areas of the house tend to get dirtier and prioritizes those areas during the cleaning. Then we have to select the software stack, okay, the right technologies and tools to develop the AI agent. So what programming languages you would choose? So you have Python, which is widely used for AI and is rich with the libraries for machine learning, neural networks, everything. Then you can use Java and C++. The frameworks which are available are TensorFlow, PyTorch, OpenCV for computer vision. Then hardware, microcontrollers and sensors for real world robots. Example, for the cleaning robot, you might use Python with libraries like OpenCV for image processing and TensorFlow for learning dirt detection patterns. Then comes implementation and testing the AI agent. First is to develop the perception module, which is implement code to collect and pre-process environmental data. Use libraries like OpenCV for image processing or sensor APIs for hardware inputs. Example, program the robot to detect obstacles and dirt using its sensor and cameras. Then add decision-making logic. Integrate algorithms in the planning module to determine actions based on goals and environmental data. Example, the robot calculates the most efficient route around the furniture to clean the entire room. Program the action module. Write a code to translate decisions into real-world actions. Example, the robot's wheels move it forward while the actuators adjust direction when obstacles are detected. Test in a simulated or controlled environment. Validate the agent's behavior in a simplified environment first before deploying it in the real world. So test the robot in a model room with known obstacles before using it in an actual house or factory areas or malls, etc. Then incorporate learning adaptability. If your agent needs to adapt to new scenarios or improve performance over the time, implement learning strategies, which are like supervised learning, like train the agent using labeled data sets, reinforcement learning, reward or penalize actions to guide the behavior, unsupervised learning, enable the agent to find patterns in data without explicit labels. Example, to train the cleaning robot to recognize different types of dirt or spills and adjust its cleaning technique accordingly. Then we have to evaluate and optimize the AI agent. First is to measure the agent's performance using relevant metrics. What are the metrics? Efficiency, coverage, obstacle avoidance. Identify bottlenecks or failures and refine the agent's modules. Example, evaluate how much area the robo cleans in a given time and refine its path planning algorithm if needed. Then deploy the agent. Integrate the agent into its target environment. Monitor its performance in real world conditions and iterate based on the feedback. Example, deploy the robo in different houses, gather feedback from users and update its software for better performance. Then documentation and maintenance. Keep comprehensive documentation for future developers and users. Regularly update the agent to handle new challenges or changes in the environment. Example, document the robo's setup instructions, maintenance requirements, and software updates for the users. I hope you like this thing. So just I can give the final word. Yeah, building an AI agent is a iterative process that combines careful planning, robust design, and thorough testing. By understanding its purpose, environment, and required components, you can create an effective and intelligent system capable of solving complex problems autonomously. Whether it's a simple virtual assistant or a sophisticated smart cleaning robot, the principles outlined here provide a roadmap to success. I hope you enjoyed this video. If you like the video, please do subscribe to my channel. Thank you very much and have a good day.